Today we're going to be talking about angles in standard position. And basically what this means is that, again, standard position implies that the initial side is starting on the positive x-axis. So if we look at our coordinate plane, again, that's over here. And then it's rotating and ending somewhere on the 0 to 360 or 0 to 2 pi circle. But it's not necessarily an angle that we know the measure of, nor is it potentially an angle on the unit circle, because if the information gave us or that was given in the problem implied something on the unit circle, we'd obviously have other ways of doing this. So if we take a look at the definition here, it says, let theta be an angle in standard position, like we just saw, with the point xy on the terminal side of theta, so that ending side, and r is equal to the square root of x squared plus y squared, which is, again, derived from the Pythagorean theorem. So r in this case, thinking back to unit circle, would imply radius if we drew a circle through that point. And the way that we find that is by finding the hypotenuse of a right triangle. So that's, again, where that's coming from. So let's just draw a random angle. I'm going to start and draw it over in the second quadrant. So here's our angle theta. And some point on the terminal side, we'll call it x comma y. Basically what's happening here is we're building a right triangle. So if I drop this altitude here, I create the right angle. Obviously the leg over here would be length x, the leg on this side would be length y, and then this is the r from the origin to that point that they're talking about. Okay, so basically we can go back to right triangle trig to find all of our 6 trig function values from the ordered pair. So in this case, the sine value on the unit circle was just y, but this time we have to incorporate that hypotenuse because r this time is probably not going to be 1. Cosine then would be x over r because it's adjacent over hypotenuse, and then tangent would still be y over x. Okay, so for a lot of these, again, we can still resort to just the values from the ordered pair, but when we deal with the hypotenuse, we do have to use that value as well. And then for our reciprocals, we'll just flip each one. So let's take a look at a couple examples of how this is going to work, and then I'll give you some time to practice for today. So the first one says that we're given the point -3, 4 on the terminal side of the angle, so of our angle theta. And we know, again, note here that they're telling us it's in standard position. We need to find the values of all 6 trig functions. So first and foremost, I would start with a sketch for a couple reasons. First, so we can draw the right triangle and label the sides, but also because we need to know what quadrant theta comes from because of the positives and negatives, so that all students take calculus still is going to apply here. So if we plot the point -3, 4, and you don't need to like make a perfect coordinate plane, I'm just going to approximate. -3 would mean to the left 3, and then we'd go up 4, so maybe it's right here, right? So the angle that opens from standard position is our theta, but remember, when we are finding values, we typically use this angle, the reference angle, anyway, so that's why we're allowed to build this right triangle to label. Now, again, the ordered pair was -3, 4. So that means that the side length on the x-axis is 3, the side length vertically, the y value is 4. And then in this case, you could use this formula to solve for that hypotenuse, but you also hopefully are recognizing here that 3, 4, and 5 are the lengths of a Pythagorean triple. So if you know that going out into the problem, you don't have to obviously use the formula. And again, this formula that I wrote down here, not something that I would bother memorizing because, again, these are all going to be right triangles, so you're really just using Pythagorean theorem, okay? Now, we want to find all 6 trig functions, so I'll just write each of them out. And then there's a process here, but you can kind of, just like with the unit circle, you can work in whatever order makes the most sense to you. So note here, I'm going to start by considering what quadrant we're in and just put the positive negatives on. So since we're in quadrant 2, I know that that means the sine value and cosecant, because that's its reciprocal, are positive. So right out the gate, I can put Maybe I'll put a plus sign on both of those. We don't typically write plus in front of positive numbers, but I will just to show you that I'm considering all the signs. But what that really means is that all of the remaining trig functions would be negative. So that's the more important part. Now I can just fill in SOHCAHTOA. So sine would be, again, opposite over hypotenuse, so 4/5, and then just flip it right away to get our cosecant. Cosine is adjacent over hypotenuse, and then flip it for secant. And tangent is opposite over adjacent, and flip it for cotangent. So basically, we're kind of combining just regular right triangle trig with this concept of angles in standard position, which allows us to build beyond the normal kind of first quadrant triangle. So note here that there's obviously going to be positive and negative values. And again, that stems from the fact that we're going into different quadrants. It does not, however, imply that any of the side lengths are negative. That's an important piece. Sometimes when I'm writing and drawing the triangle, I'll put the negatives right in on the side lengths. But again, that doesn't mean, because it'd be impossible for the side of a triangle to be a negative length. It's just where it's placed on the coordinate plane. And again, it stems back to that all students take calculus. So I'm going to suggest that you try the second problem here on your own. Note here that they did give you this, which helps you determine what quadrant to build in. So why don't you try pausing the video and setting up a sketch, see what you can get of the 6 trig functions, and then you can come back to double check it. Okay, so in this case, they gave us tangent, which is another thing that's a little bit different from the last problem. So tangent, remember, is in the form y over x. So the reason they gave you tangent is because they're just giving you the ordered pair in disguise. Now the problem is that there's a negative here and I don't know which one it belongs to. So the other part is that I know cosine is greater than 0, so that means cosine is positive. So tangent is negative, cosine is positive. What quadrant could that happen in? Well, in our all students take calculus, cosine is positive in the first quadrant and in the fourth quadrant. The problem is that tangent is not positive in the fourth quadrant. It's positive in the first quadrant. So our angle that we're looking at has to be somewhere in the fourth quadrant, right? Because if they were both positive, we could draw this in quadrant 1 and it'd be easy peasy. But since tangent is negative, we're going to use the quadrant 4 version of this. So if it's in the fourth quadrant, our ordered pair would be somewhere on this ray, and that would imply that the y value is negative instead of the x. So the x value is 4. The y value, you can see this is definitely not drawn to scale, is -5 or +5. Again, you can write it however you want, but note that that side length is not technically negative. And then to find that hypotenuse, or what we would call r in this format, we'll just take the 2 side lengths and we will square them and then simplify. So in this case, we have 16 plus 25. And of course, this does not reduce square root of 41, but if you could, like if that were, square root of 36, that's a perfect square. If it's square root of 24, then you want to break down the radical. But in this case, that's as far as we can go. So now we want to build our 6 trig functions. And again, make sure you're using that appropriate format. Note here that I'm writing trig function followed by theta, and then equals, and we'll write our fractions for each one. And again, I'm going to start by getting my positives and negatives in there. I did write -5 on the side length of the triangle, so when I'm building this, if I incorporate that, I'll see the negatives. That's kind of another way to double check. But since we have all students take calculus, I'll use it. And again, fourth quadrant is calculus. That's cosine. So again, we know cosine is positive, so I'm just going to put the negatives in for each of the other 4. And now we just build our fractions. So opposite over hypotenuse. And we do have to rationalize this, so take a moment and do that. Should be getting -5 root 41 all over 41. And note here, it was helpful for me to write the original fraction because when I write the cosecant, I'm going to get square root of 41 over 5. And again, note that that works to be negative because the 5 is the negative component of the ordered pair. So there's one negative and one positive value when we're building those. Cosine then is adjacent over hypotenuse. We're going to run into the same issue, but this time we have 4 over root 41. So 4 root 41 over 41 when we rationalize. And secant would be the reciprocal, root 41 over 4. And then tangent is opposite over adjacent. So 5/4, and of course negative, and when we flip it, 4/5. And that's really it. So what you have for today is some practice problems from the homework. And then as this is the last lesson for this unit, your problem set is still due this afternoon, and I am still making that due at 3:30. And then over the weekend, I will take a look at all of them and have them ready for you for Monday. Let me know if you have any questions, and we do have that time in the afternoon. You can reach out to me via Remind, and if we need to, we can jump on Zoom. All right, have a great one.